All right, this is another topic under the cloud in the compute in the cloud module. So in today's topic, we are going to look at elastic load balancing. Before we jump into the main topic, which is elastic load balancing, I want to introduce you to one of the most discussed topic on the internet, especially in the IT world, how the website works or how the internet works. This might come out in an interview in any way. Somebody might ask you how the internet works, or they might ask you how does the website work. Whichever way, you can give almost the same answer, but for both. So what majority of people know about how websites works is they know that, okay, you as a user, you can open your laptop, open a browser, a web browser on your laptop, then type in a website. For example, the website that we deployed yesterday, mycoffee.com. When you type mycoffee.com on the web browser, what actually happened behind the scene is that the web browser will send a request to the web server that is hosting the website. And the web browser, once it receives the request and it sees that it's coming from a legitimate source, then it responds back with the website files, specifically the file that you requested for, and it sends the file back in form of response. And that is when you see that a website display on your laptop. So this is the basic way that majority of people know how the website works. But today, I'm here to give you more details how it actually works behind the scene. It's more than this. So this takes us to another level. You as a user, when you open your web browser and type in mycoffee.com on your laptop, what actually happens is not that the web browser just send a request directly. It first do some things before it actually send the request to the web browser. And the first thing that it did, I'm just going to summarize it, is that it actually make a request to another server that is called a domain name system, which is a domain name system server. And why does it make that request? It made the request because when you type in the domain name on your web browser, the domain name is just a representative of an IP address. So the way websites and web server communicate, they use IP addresses to communicate. And when you type in mycoffee.com, which is a domain name, that is not an IP address. So the web browser needs the IP address of that mycoffee.com. So it's first going to make a request or an interaction to change that domain name that you provided. It will change it to an IP address. And the way it changes it to an IP address is that it's going to communicate, to send a request or a communication to what is called a domain name system. The domain name system is just like a server that keeps record of domain name and the mapping IP address. Like this domain name, this is the IP address. That domain name, this is the IP address. So it is the domain name server system, domain name system server that keeps that record. It has a log that keeps the record. So the browser will first send that request to the domain name server to get the IP address of that mycoffee.com. Then once the domain name system provides the IP address to the browser, it is that IP address that the browser will now use to communicate to the web server. It doesn't use the domain name.com the domain name that you provide. It uses the IP address. So whatever the website that you have interacted with in the past, they actually have an IP address. But if you are to be typing IP address on the web browser, it's going to be complicated. A lot of people will not remember any website. Today, you can count like 100 websites that you know that you visited, and you can mention them anytime. But if they are to be provided to you by an IP, in form of an IP address, then you will hardly remember one. So that is why every IP address has to be converted to domain name to make it user-friendly. But between machines, between web server and client's laptop, they use IP address and not use the web server. Please, can you mute yourself if you are not talking to the class? So when the web browser get the IP address from the domain name system server, it uses the IP address to communicate to the host server. Then the host server responds back using the IP address. So this is what happened behind the scene. And to be honest, this is just a summary. There are more components between the laptop or your client server and the domain name server. But this is enough for now. So when this happened, let's say, when you remember yesterday when we were talking about scalability, that when you have multiple people accessing your web server, when they are more than the capacity that the web server can contain or entertain, then the web server might collapse or get overwhelmed. So the question that might come to your mind is that what happens when multiple people, or does the same thing happens when multiple people visit your web server? Yes. So let's assume that from one person or few people, we have thousands of people now that are visiting our web server or websites. So the challenges now is, we need more server to cater for these people. So if we get another server to provide our web service to these people, then that means we have 2 IP addresses that we need to work with. So this is where the challenge comes. How does these people, this new user, how do they know which of the server to interact with, or which of the server to work with? And how would the browser know which of the server to send its request? Because the server, the web browser, need an IP address. So are we going to provide the 2 IP address of the web server to the client laptop? Or what if there are more than 2? Are we going to provide all of the web server to the client server, client machine? The answer is no. So what we do is that there is a middleman. When you have multiple web servers that is serving your clients do not know that you have multiple servers. They only believe you have one. They only have a particular endpoint that they visit. So it's now your responsibility that whenever this user sends a request to your web server, it's now your responsibility to be able to distribute their request among the web server that you have. If that is not done, that means all the users, they will still be sending their requests to the same server. So in order to do this, we need a middleman. called a load balancer. So the load balancer now will be the one to take the request from our clients or our customers through their laptops. We take the request that they sent through their laptop, it will take it, the load balancer will take it, and now distribute it among the servers that we have. So now, to your clients, the only IP address that they know will be the IP address of the load balancer. Will be the IP address of the load balancer. So even if you have multiple servers, let's assume you have more servers to this, they still don't need to know or bother about that, because there is load balancer that will be the one, is the load balancer that will be the one distributing the service among all of these browsers. Among all of the web browser. And if one of the web browser is not available or it goes down, then every other, the remaining web browsers, the remaining web servers, they will still continue working, because the load balancer will just be distributing traffic to those web servers that are available. So this is how we can be, or we are able to use multiple servers to distribute traffic to our end user using the same domain name. So when we go back to the cloud, there is a service that AWS provide for this particular purpose, and that service is what is called the AWS load balancing or AWS load balancer. So the purpose of the AWS load balancer is to act as a single point of contact for incoming web traffic. Any traffic that's coming to our backend, to our web servers, the load balancer is the one that is going to take that traffic. So if we have 1 million users, all of them, they will send their requests or their traffic to the load balancer. Then the load balancer will be the one distributing the traffic to our web servers. So the requests that the load balancer received are routed to the requests that are routed to the load balancer. The load balancer will then take that request and share it or distribute it among the servers that are available. So remember yesterday we talked about auto scaling. So auto scaling and load balancer now can work together. Remember, auto scaling will create some servers. Auto scaling will create some servers. If we are short of servers, auto scaling will create the servers. Maybe we have multiple users now, so auto scaling will be the one creating the server, while the load balancer will be the one distributing traffic to these servers. So both auto scaling and load balancer, they work together. So our load balancer now automatically distributes traffic across multiple servers or multiple resources. And finally, it works together with auto scaling. I said that earlier. So let's look at their relationship. If you can see the architectural diagram, like somebody that was asking for architectural diagram yesterday, this is how it looks like. We have all these users. They need our web service. And the web service is hosted on a web server. So each of the web server have a specific or different IP address. You can see they have different IP address. So we can't give this IP address to the user because they won't know which one of them to interact with. And at the end of the day, all of them might be interacting with just one single one. So in order for this not to happen, we put a load balancer between the users and the servers. So the load balancer is what the end users will be communicating with. And the load balancer will be the one distributing the traffic that is the traffic that are coming from the end users. While the auto scaling will be monitoring the traffic that are coming in. If there is need, like if there is need to create more servers, if there is need to create more servers, maybe these 4 servers is not enough again, then the auto scaling will create additional server. So the end users they don't need to worry about, oh, what is the IP address of the new server, because they are not even interacting directly with the server. All they do is interact with the load balancer. And the load balancer is the one that monitors, oh, there is a new traffic, there's a new server, it now starts sending traffic to the new server. If any of this server goes away, it stops sending traffic to that server. So one additional benefit of the load balancer is that it also monitors each of these servers. It monitors their health check. It checks their health, whether they are good or not. If any of this server is not responding, maybe it's faulty, the load balancer will not send traffic to it. It will not send traffic to it. If another one too is not responding, it will stop sending traffic to it. And maybe later, one of the server that is not responding comes back to be responding, then it will continue sending traffic back to that server. So this is the purpose of the load balancer. Any question before we move to the demo? Any question? All right. So since there is no question, that means you guys understand it perfectly. So let's go to the console and let's create our load balancer.